Okay, today we're going to talk about polyatomic ions. You do not need to write the chart. You do not need to write the chart. Okay, so polyatomic ions are defined as two or more nonmetals, circle that when you write it, nonmetals bonded together. And they act as a single unit with their own charge. A single unit with their own charge. The only thing that I would like to point out to you is if the original is named phosphate, and you can tell on your EOC chart, this phosphate will have a -3 charge. If you remove one oxygen, it changes the name to phosphite, but it does not change the charge. Okay, let's look at your EOC chart for pictures, for the listing of your polyatomic ions. Did you find them? Okay, got them? Here they are. Here they are. Okay, you will notice, by the way, you can use all of these on any test and the EOC. What I want to point out to you that it's sometimes kind of difficult to see, hang on for a second, is this. We'll be using them, rewriting them like this because it's a little less confusing. We'll be putting them in parentheses. So you see that the two nonmetals are bound to each other, and then together the carbon and 3 oxygens have a -2 charge. See how they're kind of squished together there? Okay. So the chromate polyatomic ion is CrO4 with a -2 charge. Everybody good there? Okay, don't let this one fool you. Hydrogen carbonate. Hydrogen carbonate. If these 3 types of atoms are all bonded together to form the polyatomic ion. What does poly mean? More than one. What does the atomic refer to? Atom. So this is saying to you, these are more than one atoms that act as an ion. Do you get this? More than one atom that act as an ion. If you look at your, watch this. If you look here, pretend you're on Sesame Street and play the one of these things is not like the other game. What do you see that's different?
Don't you?
Push it right there.
No, that's new. One of these things is not like the other. What is not like the other? Thank you. Help from the audience, folks. What did he say?
Positive charge.
Positive charge. All of these have negative charges with the exception of ammonium. It has a positive charge, so in an ionic compound, it will act as the cation or anion?
Cation.
Cation. All of the rest of these would act as the
Anion.
anion. And when you're writing an ionic compound, which goes first?
The cation. The cation.
Cation goes first. Why?
Because it's positive.
Because it's positive and cats are better. So it's cation and then anion. All right, everybody good there? Okay. I'm going to let this guy on YouTube teach you how to write the formulas. Pay attention, okay?
Yes, ma'am.
Hey guys, it's Mr. Post, and
He'll be back.
today's video we'll be determining the formula of ternary ionic compounds and also learning about polyatomic are polyatomic ions? A polyatomic ion is simply a group of elements that act as one, and they carry one charge. And a good example of this is the first one we look at here, carbonate. Carbonate has carbon, it has oxygen as well, and together those two carry a 2- charge. And so, just so we're crystal clear here, that's one element, and that is the second element. And I'm not really worried right now about how many of that second element I have. The point is, I want to show you I have 2 or more different elements that together hold one charge. That is one charge. Another one I can look at down here is ammonium. Ammonium is made up of a group of elements that is made up of more than one element. It is an ion because it has a charge. I have my first element here, and I have my second element here. So I have nitrogen and hydrogen, and together they hold just one charge. And that charge in this case happens to be 1 positive. That 1 positive is distributed over the whole entire polyatomic ion. It is not that hydrogen has 1 plus, but that both those elements together have a 1 positive charge. Not that we're going to look at every single one of these, but here is a small list of polyatomic ions. We have ammonium in the upper left-hand corner, followed by carbonate right below it. And once again, this is a carbon, oxygen with a 2- charge. So it's carbonate is CO3 with a 2- charge. That 2- charge goes on the whole entire CO3. We have cyanide down here, and that has a 1- charge. Moving down a little farther, I have bicarbonate. And this whole entire bicarbonate structure here has a 1- charge. And this is what is known as a polyatomic ion. More than one element, polyatomic, that carries a charge. This leads us to the next topic, the ternary ionic compound. A ternary ionic compound is simply an ionic compound that is made up of 3 elements. Here's our 3 elements. We have calcium, phosphorus, and oxygen. Calcium is the first element, phosphorus is the second element, and oxygen is the third element. So I have an ionic compound made of 3 different elements. Okay guys, here we go. We're going to now work on determining the formula unit for sodium carbonate. Alright, so this is sodium and carbonate. We have an ion of sodium and an ion of carbonate. And together they're going to come together to form the ternary ionic compound, sodium carbonate. And this is no different than what we've done beforehand. We've actually taken Na, which is the 1+ charge, and we're going to take carbonate now. And just as we've done beforehand, I want you to cross the charges. Bring that 2- over next to sodium. We're going to bring 2 there, and we're going to bring the 1 all the way over on the other side of carbonate. And so what I end up now with is Na2CO3. And anytime I have just 1 as my subscript on the outside, you are aware that we never really write the 1 if it's there. In the same way, if the 1 is there, we remove the parentheses. So
If the 1 is there, you don't need the parentheses.
CO3. And that is my ternary ionic compound for sodium carbonate. Okay, the next one is going to be calcium chlorate. So I'm looking at calcium chlorate. I want to draw the polyatomic ion. Why don't you press pause and attempt to do me the formula of calcium chlorate. Okay, hopefully you made an attempt. I'm going to take it.
Make that attempt.
Oh my gosh.
Put your pencil down when you're done, so I know you're ready.
As Ca has a 2+ charge, chlorate is a ClO3 with a 1- charge, and I'm going to cross those numbers. The 1 is going to be crossed over here, and the 2 is going to be crossed on calcium chlorate. Here's another one, guys, calcium sulfate. Calcium sulfate is a ternary ionic compound. Please cross the charges and give me the formula for this ionic compound.
Did you do it?
Press pause, please do it yourself. I'm going to take calcium, which has a 2+ charge. I'm going to take sulfate, which is SO4. It's an SO4 there, with a 2- charge, and I'm going to cross those numbers. The 2 comes over there, and the 2 comes over there. And whenever I have 2's, they reduce down to 1 and 1, and this just is simply written CaSO4. That's calcium.
How many people got that right? Good
I
job.
forgot to
Remember,
reduce it
reduce when
down.
you can.
Oh.
Sulfate. So determine the formula unit of CaSO4. The last one we're going to try today is aluminum nitrate. Once again, please give me the formula unit, press pause, take your best effort. Okay guys, aluminum is a 3+ charge. Nitrate is NO3 with a 1- charge. And we're going to cross the 1 over here and cross the 3 over there. And although I'm not showing you what I'm doing, I am crossing the 3 this way and crossing the 1 over there. And this 3 actually ends up right there. That's where I'm crossing to. And what I end up with in this case is Al1 and NO3 with some parentheses on 3 of them. So once again, I cross my 3+ all the way over there and cross my 1 all the way over here. And the formula unit is AlNO3. Alright guys, that concludes our lesson on ternary ionic compounds, which involve polyatomic ions. Please review it if you need to refresh yourself. Otherwise, I hope you know. Beth?
Wait.
Got it?
Yeah, you got it.
Okay. Now I can move it. Thank you. Okay, it shows part of something I don't want on the internet. Thanks. Okay.
Sorry,
Now,
guys.
let's talk about writing formulas. I think you got. Let's talk about writing names. Here's the procedure. Why are you laughing?
Sam, tell her.
Why, he was instrumental in success here.
No, he whispered to the camera. Sorry, guys.
Write the name of the monovalent metal first. Write the name of the polyatomic nonmetal from the chart. This works for all of them except which one?
The monovalent. No, the multi.
Ammonium.
No.
Ammonium,
that's good.
right,
Oh.
ammonium. Ammonium would go first because it's cation, and then you would just write whatever the nonmetal is as you've done for all the rest. So, we write the metal, potassium. We write the nonmetal, sulfur. Let's practice with ammonium.
Isn't O oxygen
Remember, this is a polyatomic ion
Oh.
from the chart. To name this, we would write the name of the polyatomic ion, ammonium. It's the cation, it comes first. And then we would look at this. This is sulfur, so it would become sulfide. All right.
Wait, don't you write the polyatomic nonmetal bond?
This one is the only one that has a +1 charge. Remember? Look on your EOC chart. So it is the only one that acts as a cation. Why don't you write yourself a note in your notes right now? Ammonium is the only cation. Goes first. Okay. Here is the procedure for writing the polyatomic when you have a multivalent metal. Write this down. So you write the name of the multivalent metal first. Write the Roman numeral that tells you the charge of the multivalent metal. And we are going to remember the Beyonce rule from yesterday.
To the left, to the left.
Thank you. To the left, to the left. The Roman numeral tells you the charge of the atom to the left. And you're going to write the name of the polyatomic ion. What is not written right here?
The charge.
1. What is not written right here? 1. Can you uncrisscross this? So now you know that the copper has a charge of 1, so it becomes copper 1 nitrate. I'm going to trick you right this moment in time. Are you ready?
Yes.
Another way to write this. Look, it looks like Alpo, the dog food. Name this.
Aluminum, aluminum delivery.
Roman numerals or not?
Yes.
No. Why not? Aluminum is in Azkaban. Aluminum is in Azkaban. What part of Azkaban is it? Right there, aluminum. This is silver, this is zinc, this is cadmium, this is aluminum.
Why'd you put it? AG.
Silver, Ag, Zn, CdAl. Got it? Alrighty. Let's try this. Look, it looks like nacho.
Yeah, but it's nacho cheese.
Do not write that as the answer, because it's not right. Hmm?
She purposely do that?
I do that all the time in AP chemistry. Whenever I need a compound, it's always nacho. I see people picking up their EOC chart. Way to go. Okay, don't peek. I'm gonna write the answers so I can stop filming. Don't look at the answers up here. Just look down at your paper. Brittany, I can see you peeking. As you finish, you may look at the answers.